In the diagram, line 1 has the equation y equals 2x plus 6 and crosses the x-axis at P. What is the x-intercept of line 1? Okay, well, to find the x-intercept, you set y equal to 0. So you would set that equal to 0. And when you do and solve for that, you get x equal to minus 3. So the x-intercept is going to be minus 3, 0. And that's this point right there. Point P. Line 2 has a slope of negative 3 and intersects line 1 at 312 as shown. Determine the equation of line 2. So the equation of a line is y equals mx plus b, where m is the slope, and they've told you that is negative 3. So it's negative 3x plus b. And then we can just substitute this point in to solve for b. When y is 12, x is 3. And when you solve for this, you get b equal to 21. So this equation is y is equal to minus 3x plus 21. Part C, line 2 crosses the x-axis at R as shown. Determine the area of PQR. So the area of that triangle PQR would be 1/2 base times height. So this is the base and this is the height. Now the base is from here to there, and the height we can just use that perpendicular distance, which would basically be the y coordinate of that point. So that immediately we can just put in 12. Now once we get the base, then we're all set. To get the base, we would obviously have to find r. To get r, all we have to do is just take this equation and find the x-intercept, and we can easily do that by setting y equal to 0. And when we do, we get x equal to 7. So this is 7, and this was minus 3. So from minus 3 to 7 is a distance of 10. So that's what goes there. And therefore the area would be 1/2 times 10 times 12, which is 60. On Wednesday, students at 6 different schools were asked whether or not they received a ride to school that day. At school A, there were 330 students who received a ride and 420 who did not. What percentage of the students at A received a ride? So it would be 330 divided by 330 plus 420. And when you do that math, it comes out to, I think, 44%. Part B, the school B has 240 students, of whom 30% received a ride. How many more of the 240 students in school B needed to receive a ride so that 50% of the students got a ride? Okay, so 50% of the students in school B. Now first let's figure out, of all the students, how many received a ride. So it's 30% of 240, right? So that is 72. Now if we want 50% of this 240 to receive a ride, that's going to be 120 students. So we want to go from 72 to 120. And that would mean we'd have to add an additional 48. So 48 more students would have to receive a ride in order for 50% of the students to have received a ride. School C has 200 students, of whom 45 received a ride %. School D has 300 students. When school C and D are combined, the resulting group has 57.6% of the students who received a ride. If X % of the students at school D received a ride, determine X. All right, so the school C, so let's just write the school name here, if I can spell the word school. School C and school D. So school C, we have 200 students, of whom 45% received a ride. So that's 90 students who received a ride. School D, we have 300 students, and X % of the students received a ride. So it's X over 100, and whatever that works out to, it's 3X. Now what they're saying is they want you to combine those two, and they want the end result to be 57.6. So if you combine those two, it'd be 90 plus 3X, and then over the total, which I believe was 200 and 300, right? 200 for school C and 300 for school D, and then that is going to be your 57.6%. So 57.6 over 100. And there you go. That's the equation you'd have to solve, and we can do that. It'll be 90 plus 3X And then it's 500 times 57.6 divided by 100. And when you do that math, it gets to 288. Now 3x is 198. And x comes out to be 66. So there you go. School E has 200 students, of whom n% received a ride. School F has 250, of whom 2n received a ride. When school and E and F are combined, between 55 and 65% of the resulting group received a ride. If n is a positive integer, determine all values of n. All right. So very similar to the previous question. It's just a little bit different with regard to the lettering. So again, we have school E this time and school F. So school E, it's 200 times n over 100. And that's just 2n when you do that math there. School F is 250 times 2n over 100. And that is 5n, I believe. And then they're saying that you have to now combine these. So 2n plus 5n over 200 plus 250, right? And that is between 55 and 65%. Okay. So I'm going to have to do two calculations. I'll first do it for 55. And then I'll do the same thing, but this time for 65. And then we'll look at the values of n, and then we'll talk about what possible integer values we can get. So when you do this, I'll let you figure this out, fairly straightforward. It comes out to 35.3. And when you do this guy, this equation, the n comes out to 38.5. So that means that my n is between 38.5 and 35.3. Now n is an integer, so that means n can be either 36, 37, or 38. In this range, those are the only integers. If n plus 5 is an even integer, state whether the integer is n is even or odd. All right. So if n plus 5 is even, well, let's see here. If n plus 5 is even, so let's say, I don't know, 12, that's an even number. That would mean that n was a 7. So that means n is odd. Correct? So if n plus 5 is an even integer, that means it's like 2m. And therefore, n is equal to 2m minus 5. And that basically means n is equal to like 2m plus 1 minus 6. And this is an odd. And when you take an odd number and subtract from it 6, it's always going to be odd. Any odd number, try it. So if, like, for example, 11 minus 6 would still be 5. So whichever way you want to prove this, is fine with me. They just want you to come up with the right answer, which is odd. All right, part B, C and D are integers. Explain why CD times C plus D is always even. Okay. So C and D are integers. They don't tell us if they're odd or even. So I guess we've got a whole bunch of cases here. We got C and D, and we got to look at different cases. So the first case is when C is even and D is also even. And the next case is when you have even and odd. And it's interchangeable. Either C is even and D is odd, or C is odd and D is even. I don't think it matters. Yeah. And then the last scenario is when they're both odd. So let's see what happens with either of these. So if something is even, it'll be of the form 2m or 2n. So let's put those in there. And if it's odd, it'll be like 2n plus 1 or 2m plus 1. So we have to sort of play with those values. Okay, so let's do scenario 1. And remember, we're calculating CD times C plus D. C plus D. All right, so let's see what happens. So we have 2m times 2n times 2m plus 2n. And this becomes, what does it become? 2 times 2mn times 2m plus 2n. Now, the reason I sort of arranged it like that is because there's a 2 out front. And anytime there's a number 2 and multiplied by anything, it's even. Because all even numbers are of the form 2k. So whatever this k is, it doesn't matter as long as there's a 2 out front. it's even. So we proved that this is even, this scenario. Now let's look at that scenario. So this time it'll be 2m times 2n plus 1 times 2m plus 2n plus 1. Okay. And I think it's pretty much the same story here. So you can just put the 2 out front, and then you just have this m, and then 2n plus 1. Same thing, and just rearranging it a little bit. And then because you have that 2 out front, it's even, because it's of that form. All right, so that takes care of that. Now let's look at this guy. So this will be 2m plus 1 times 2n plus 1 times 2m plus 1 plus 2n plus 1. Okay. All right, so how does this work here? What can I do here? I think these guys, not much I can do. I'll just leave it at that. But I think I can factor out a 2 from this guy. And this becomes m plus n plus 1. Yeah. And therefore you got that 2 again, and then a whole bunch of other stuff. So again, it's in that form again. So that's pretty much all that is. This wants you to put everything in this form. Determine the number of ordered pairs EF of positive integers where E is less than F, E plus F is odd, and E times F is 300. So now we have a little bit different of a scenario here. So let's see what we can do. E is less than F. E plus F is odd. And then we have this condition that E times F is equal to 300. So I'm going to concentrate on this guy here. Let's just make a table of E and F so that when you multiply them together, they give 300. And it's they're integers, right? Yeah, they're positive integers. Okay. So I have 1 and 300, 2 and 150, 3 and 100, 4 and 75, 5 and 60, 6 and 50, 7 won't give me an integer, 8 won't give me an integer, 9 won't give me an integer, but 10 will give me 30. And then the only other ones are 12 and 25 and 15 and 20. And because E is less than F, we can't go any further than this, because if we did, E would not be less than F. Okay, so we took care of this guy and this guy. Now we have to start concentrating on which one of these has a scenario where E plus F is odd. So E plus F. Okay. All right, so let's see. Shouldn't be too hard to figure this out. E plus F here is odd. This one is going to be even, so that one I won't count. This one is going to be odd. This one is also odd, I believe. This one is also odd. This is even. This is even. This is odd, and this is odd. So looks like we got 1, 2, 3, 4, 5, 6. 6 ordered pairs. And I guess you can just list them, right? They just want the number, but just for the sake of completeness, you can list them all. So that's pretty much taking care of that part. Part D, determine the number of ordered pairs mn of positive integers such that m plus 1 times 2n plus m is 9,000. Okay, so very similar to before. We want to make a table, but let's see what happens. I don't think this is going to work out nicely. What I mean by that is going to be tremendous amount of work. Because now, if you notice, we don't have 300 this time. We have 9,000. So you're going to have 1 and 9,000. You're going to have 2 and 4,500. You're going to have 3 and 3,000, and so on, right? 4 and 2,250. And this is obviously going to go on forever. Very, very time consuming. Now, let's say I wanted to go this route. How would you do it? Well, you take one of these. So I'm going to go with something that's actually going to give me integer values for m and n. And I believe this is the first one. So that means that m plus 1 is 3. And 2n plus m is 3,000. Now, this is easily solved. That means m would be 2. And this, if you sub in m equal to 2, this gives you a value of n is equal to 1499. So we got one ordered pair of 2, 1, 4. Oops, I put it in the wrong place. It's here. Sorry. 2, 1, 4, 9, 9. Okay, great. But as you can see, you'd have to do it for numerous scenarios, and that's way too time consuming. And there's no way you're going to do that. So how do you shortcut this question? Well, you shortcut it by looking at something called parity. And parity refers to whether something is even or odd. And when you look at it from that perspective, you'll be able to narrow this down to only about maybe 6 or, I think 6 values rather than countless values. So here we go. So we're looking at n and m. So first, if n is even, that's our first scenario, we're going to see what happens. If n is even, then I'm really concentrating on these two guys, right? M plus 1 and 2n plus m. If n is even, 2n is even, and therefore 2n plus m would be even if m is even, correct? And 2n plus m would be odd if m is odd. Now, if m is even, that would mean m plus 1 is odd. And if m is odd, that would mean m plus 1 is even. Correct? Hopefully that made some sense. So that is this scenario here. Then the other scenario is if n is odd, then 2n is even, right? Even if it's odd, if you multiply by 2, it becomes even. You can try it, right? 7 is odd, but if you multiply by 2, it becomes 14. And then if 2n is even, then we have the same kind of story again. So what that means is these two guys up here, m plus 1 and 2n plus m, have sort of limited scenarios based on parity. You notice that if n is even, and we went through this whole scenario, we got this result right here. And that basically said that if 2n is even, m plus 1 is odd. If 2n plus m is odd, m plus 1 is even. So if we write these two guys again, m plus 1, 2n plus m, just like we did up there, right? This guy and this guy. From this parity discussion, we can see that they will always have opposite parities or different parities. So if one is even, the other one is odd. If one is odd, the other one is even. And that's very helpful. So they will have different parities or opposite parities, since there's only two parities, right? There's odd and even, and that's it. So m plus 1 I will call A, and 2n plus 1 I will call B, and then I'll make the table. All right, so far so good. Okay, so going back to our original formula, if I remember, it was m plus 1 times 2n plus m is equal to 9,000. But I've substituted a and b, so it's a, b is 9,000. Okay. And then a times b, and this 9,000 I'm going to break up into prime factors, so it's 2 to the power of 3, 3 to the power of 2, and 5 to the power of 3, I believe. And now let's talk about this. If one is even, the other one has to be odd. So that means if a is even, then b has to be odd. If that's the case, that means that a has to have all these 2's. That's the only way that b can be odd, because if b had any of those 2's, it would be even. So that means that a has to have all those 2's. It has to have that full 2 to the power of 3. And then the other stuff we don't know, so I'll just call it r. And then b has something, so I'll just call it s. So that means a is essentially just 8r, and b we can call s. Right? Don't get too confused. Just follow the steps here. That's the first scenario. The other scenario is that a is odd, and then b is even. So the same story, if b is even, it's also got to have all the 2's. So b would basically be 2 to the power of 3 times some s, and a would be something I don't even know, so we'll just call it r. So b is essentially 8s. So now let's go back to this guy right here and substitute what we have. In either case, whether you do 8r and s or r and 8s, this now becomes a times b becomes 8rs is equal to 9,000. And then that means rs would be 1125. And if you break it up into prime factors, it's 3 to the power of 2 times 5 to the power of 3. Okay, so now this is a little bit more digestible. So now if we make a list of r and s, you'll see that there's far less choices. So the first is 1 and 1125, 3 and 375, 5 and 225, 9 and 125, 15 and 75, and 25 and 45. As you can see, that's far less than our previous one up here, which would have been, very time consuming. Okay, so now we got this. We can now make a list for A and B. Now A, remember, we have as 8R and B is S. And you just solve this. So this would be 8, and this would be 1125. Or sorry, 1125. Exactly what I said. And this will be 24, 375. Let's see here. The next one is 40 and 225. And then 72, 125, 120, and 75, and finally 245. Okay, so, but we don't want A and B, we want M and N, remember? We want M and N. Well, A was representing, if you remember, what was A representing? A was representing this m plus 1 guy, and B was representing 2n plus m. So that means A is m plus 1, and B was 2n plus m. So let's do the first one here. We have 8 is equal to m plus 1, so that means m is equal to 7. So put that in there. And then for this one, this becomes B is what? 1125 is equal to 2n plus 7. So when you solve this guy, you get n is equal to 559. So there you go, 559 for n. And that solves the first one. So we got one ordered pair. And similarly, you do it for all the other guys. And when you do, you get this table. So as you can see, I had done it for the first one, and I got this guy right here, the first one. And you just do the same kind of calculation to get all the other ones. Now, this, what I did up here, takes care of this part of the table, right? Now, the other part of the table, this guy over here, that you get when you interchange R and S. Like, for example, here I had put A is equal to 8R and B equal to S. But you can also do the other way, which is A is equal to S and B is equal to 8R, right? So, for example, A is equal to S and B is equal to 8R. And AB is multiplied together is 9,000, right? So this would be 1 and 9,000, 3 and 3,000, like that. 5 and 1,800, and then 9 and 15, 9 and 1,000, 15 and 600, and 25 and 360. So, yeah. So that is the scenario for this guy right here. And from that, if you do the similar calculations like I did here, that's how you get these guys. And you notice one's missing because this one would give you m equals to 0, and that's not allowed because I believe they have to be positive integers. So that's why there's only 5 listed there. So there you go. That's how you do this part. In the diagram, square BCDE has side length 2, equilateral triangle XYZ has side length 1, vertex Z coincides with D, and vertex X is on ED. What is the measure of angle YXE? Okay, YXE. Okay, so they want that angle in there. Well, this angle in there will be 60 because it's part of an equilateral triangle, so YXE would basically be just that 180 minus 60, which is 120. A move consists of rotating the square clockwise around a vertex of the triangle until a side of the square first meets a side of the triangle. The first move is a rotation about x, and the second move is a rotation about y, as shown in the diagrams. In subsequent moves, the square rotates about vertex z, then x, then y, and so on, determined with justification the total number of moves made from the beginning of the first move to when vertex D next coincides with the vertex of a triangle. So we want vertex D to coincide with a vertex of the triangle. It doesn't matter which vertex, just any vertex. Now this diagram shows when you make those actual rotations based on the way the question is describing how those rotations are made, this is how the triangle ends up. So as you can see at the end of the first move here, the triangle ends up so that y is at vertex E at the end of the first move. At the end of the second move, y is still at E. We just rotated it again. And then third move and so on. And when you continue this process, the next time that the vertex D coincides with the vertex of the triangle is right here. As you can see, vertex D is coinciding with y, the y vertex of the triangle. So you just have to rotate it and see when is the first time that D coincides with the vertex of the triangle, and that would be after 7 moves. Determine the length of the path traveled by point E from the beginning first move to when square BCDE first returns to its original position. That is when D next coincides with Z and XZ lies on ED. So the first thing I want to do is sort of show this table here because this is very important. It kind of goes along with the previous question, but it gives you a nice little summary of what is happening. Initially, D and Z are coinciding, and then when you make a move, what happens, after the first move, second move, and what is the angle of rotation? That's also very important. So this is a very nice summary of what happens, and as you can see, as we talked about in the previous question, the first time D coincides with a vertex is after the 7th move. Okay, great. So that means that after 8 moves, we have D at Y, as they show, and Z is now back on DE. Okay? And then that is the same as sort of a pattern that it kind of, in a very predictable way, will kind of end up in a certain place. So it looks like every 8 moves, it comes back in a certain way. So that means that after 16 moves, I would predict that D and X would be basically how the vertices would coincide, and Y would be on DE, like that. And then after 24 moves, D and Z would coincide, and X would be back on DE. So this is what they're asking. D coincides with Z, and XZ lies on ED or DE, whichever way you want to look at it. So really, based on this pattern, I would say that 24 moves is how we have to proceed. Now, these angles are going to be very important, but we also have to figure out now the distance. And during each rotation, the distance traveled by E, which is what they want, right? They want the distance, the length of the path traveled by E, this guy, is calculated as follows. Every time there's a rotation, the point on the square is rotated about the center of rotation through the angle of rotation of the square. So that means the distance traveled by E is the fraction of the circumference of the whole circle given by the angle of rotation as compared to 360. So the total length would be a fraction. So whatever angle you traveled by, you divide it by 360, and then you multiply by the circumference, which is given by the formula pi 2r. And the angles are here, and this has been calculated by basically looking at how the rotation took place. And then what you have to also do is you have to figure out these radii, I guess. So if these radius calculations are not obvious, I'll do them for you. So we had the square, right? And the square was E, B, C, and D. Now, if you're going from E to D, that's 2, because they told me that the side length of the square is 2. And then E to B is also 2. So that's pretty straightforward. But what if you're going from E to C? That's a diagonal. So you'd use Pythagoras, and EC, of course, would just be, EC squared would be 2 squared plus 2 squared. So then EC is calculated, and you get 2 root 2. Now, what if you're going from E to one of these midpoints here? Let's say you're going there, E to F, or this guy here, let's call that G, E to G. Well, that would mean this is 1 from F to D, so then EF squared would be 2 squared plus 1 squared, and that would mean that EF is root 5, I believe. So that's how we got these radii. As you can see, it's either 1 or 2 or root 5 or 2 root 2. So that's how we got the radii. And then now, to figure out the total, you would just calculate it as follows. So we had 8 moves, right? So the first move, the angle is 120. So remember, using this formula. So it'd be 120 over 360. And then pi 2r, and then r in this case is 1. And then second move, the angle this time is 30 over 360. And then pi 2 0 this time, okay? And then you just keep going. So then this will be 120 over 360 pi 2 times 1. Correct? And then 30 over 360 pi 2 times 2 plus 120 over 360 pi 2 times root 5. How many have I done so far? 5, right? Yeah, I've gone to here. So I got 3 more. So the next one would be 30 over 360 plus 2 pi times 2 root 2. And then 120 over 360 times 2 pi times root 5. And then finally the last one, 30 over 360 times 2 pi times 2. All right, great. But that's only 8 moves. We have to do 24 moves. So the next 8 are the exact same, and then the next 8 are the exact same in terms of these values and these values. So whatever this is, we would have to just multiply by 3, because this was for the first 8 moves, but we have to do 24 moves, and the next 8 and the next 8 after that are the same. So whatever this is, you just multiply by 3. So it becomes 3, and when you do all this math, it becomes 2 pi plus 4/3 root 5 pi plus root 2 over 3 pi. And then when you multiply by 3, it becomes 6 pi plus 4 root 5 pi plus root 2 pi. And that is the total distance traveled for E over the first 24 moves. And when you do that, you get back to the position that you wanted, which I believe right here. Determine the length of the path traveled by E from the beginning of the first move to when square BCD first returns to its original position. Okay, there we go. That would be the distance traveled for E from the beginning to when it gets back to its original position after 24 moves.